So my name is Jerel Unruh. I'm a back-end developer at Toyota Connected. And at Toyota Connected, we do car sharing, car rental, fleet management, and we use Elixir for our back-end. We process vehicle telemetry, do vehicle scheduling, the typical things you would imagine being involved in a car rental system. So I'll start with the age-old question of why am I here? This talk is basically a number of things that I've ran into, bumps in the road, things I've learned in moving from a small project to a project with a number of developers contributing to it. That project, being a large code base, needing pieces carved off and deployed elsewhere, running in multiple regions, some of that stuff. So this talk is broken up into 4 different sections. I'll start with a short section on keeping a code base neat, just a couple of little tweaks. Starting off with mixed format. I know Jose said that he wasn't going to talk about mixed format anymore, but I guess the rest of us haven't made that promise yet. But mixed format I found to be quite handy in keeping different developers, keeping their code similar so we can read each other's code. We had used Credo early on, and one of the benefits I see with mixed format, is that it's not configurable. It just is what it is, part of the language. So with compiling, as far as keeping out unused variables and a few things like that, I discovered this here flag a while back, warnings as errors, and started using it in the CI pipeline. And what you can do is you can run deps compile first. That compiles all your dependencies and doesn't worry about the warnings in those, because your dependencies often will have deprecation notices, that sort of thing. But in your own project, you can run this last line, mix do compile warnings as errors, and then run your tests. And if there's any warnings in your code, it will exit with a non-zero exit code and stop your CI build. That can keep any one of us from accidentally committing things that throw warnings and then letting them accumulate until you have different messy things in your code base. And if you want to, you can add that as a option in your mix.exs file for your project. So releases, I'm kind of a fan of releases. I really like what they produce. It's not quite like Go's single binary that you can deploy just anywhere, but it does produce a compact tarball needing everything you need. And it seems to me like releases are less forgiving than running, say you're just going to run mix Phoenix server in prod environment or something. Seems like you can get by with more things like circular dependencies and some undesirables like that, whereas distillery will warn and will tell you if you're missing apps that are needed by apps in your project. And I think that's a good thing. It stops that early on. So I like to use releases right out of the gate on a project. And with the default mixed release, you get you give it a name and it produces a release by that name, but you can also pass a name in and have multiple releases configured per like in your rel config file. So let's say you want to start some apps on one server, start different apps on the other server. You can do that with releases producing an artifact. And then in your bin folder you get a executable by the name of your release, which in this case I named Bellevue for my sample application. And remote console is, I find, to be a very handy command. I end up using it quite a lot for debugging things in dev and so on. Let's say that configs don't get applied the way you think they would or something, you can SSH into a box, run remote console, use application get env or whatever command you need in order to diagnose something that's running in a prod environment, probably in your dev stack. So next section here, I'd like to talk about test stability just a little bit. Early on, we were using a CI provider that just gave it turned out only a single CPU, which isn't ideal for OTP. It can leverage a lot more than that. And currently, we're making use of Circle CI, which I like quite well. And I'd like to talk just a little bit about some configuration things we did there. You'll notice on the left side of the screen, we have a job called build test. And what that does is it compiles dependencies, and then it caches the build folder, and it uses the mix lock file as a checksum. So it doesn't matter which branches devs are working on, as long as they're using the same mix lock file, the same compiled assets can be used from build to build, and that speeds things up quite a bit. You notice the job on the lower left, build release, that's running a distillery release. That's taking 3 minutes and 25 seconds. And that one is starting from scratch each time, so it's always doing a prod deploy no matter what. But build test is quite a bit quicker. Then we move on to the test stage, and what that does is run the tests in all the apps in the umbrella project. And lastly, if the tests pass, then it deploys to a dev environment. So just a little adjustment here. Circle CI allows you to run a CLI command, gives some extra tools, and one of those is splitting a directory by timings. And what we've done here is inside that test job that I showed on the previous slide, there are 4 parallel tests, or 4 parallel environments being spun up by Circle CI. And the Circle CI test split command iterates over all of the apps in the umbrella project and then divides them up by how long it took each of them to run on the last build. And then it assigns each one to one of these 4 parallel jobs. And you can have any number of those depending on how many apps are in your project. You wouldn't need to have one for each app because a lot of times in a project, one app is going to be longer than the others. So I'd like to talk just a little bit about Ecto Sandbox. By default, this is usually how I use the Ecto Sandbox in XUnit. Using shared mode, this will typically be put in a test helper or something. But what this does is it allows all child processes to access the Ecto Sandbox checkout that the test process has done. And where I have ran into trouble with that in a larger project is, let's say you have a process that's doing something of this nature. This is a contrived example, but you have a worker process that 10 seconds after it starts, it queries the database, and then every 10 seconds thereafter, it queries the database again. Well, this won't cause any problems to start with. We have a supervisor that starts one of those workers. On line 10 there, it's specifying that worker module to start. But you start writing tests, and here we have one that is completely unrelated to that worker. Does nothing with the worker, just tests a function. And that'll be fine until you have a large number of tests. And once your test suite starts taking long enough, you'll start seeing this. Database connection error, cannot find ownership process. And the issue with this is that worker, you really have no way of associating it with the test process. It's something completely unrelated. It's running off to the side. And the approach that I've started taking with that is using mixed test no start in a project. So what you do then is you manage the processes starting manually by using Start Supervised. I think Start Supervised was added somewhat recently in XUnit, one of the last couple releases. But on line 7, you do Start Supervised to start that supervisor. And what that does is it connects that supervisor process as a child of the test process. So then all of the children of the supervisor also will have access to the same sandbox. And now, when the test process ends, it will shut down the supervisor. So it'll shut down the children first, then shut down the supervisor, and then the test process will exit. So lines 5 and 6 is sort of a shorthand for starting all of the dependencies you might need. So if you're using Ecto, you would need to have PostgreX started, you need to have Ecto app started, and lines 5 and 6 will start all of the dependencies of the app you're currently testing. So this is what I've ended up putting in most projects as an alias. You can put this in your mix.exs file, and it just changes your mix test command to run Ecto migrations and then run test no start. The next section, I'll talk about a couple of ways to organize an umbrella project, ways to organize Phoenix, and actually run multiple Phoenix applications in one umbrella. Starting with Phoenix PubSub, I really enjoy Phoenix PubSub. I found it to be very powerful, and we use PG2 for cluster communication right out of the box. It does have limits. I discovered a while back I was doing something where a huge number of events were generated all at once. There was some data that I did calculations on, and as a result of those calculations, broadcasted something for each of those items, and ended up being able to overflow the PubSub mailbox. So it's not magic. It does pay attention to what you're asking of it. But by default, the PubSub in a umbrella project is generated as part of the web application. I think the Phoenix guides talk about doing 2 applications, one for your business logic, one for web. And you end up with a dependency tree that looks a bit like this. You have, on the lower side here, we have app A web, and then above it, it depends on app A, and which depends on app B, which is probably where you have a lot of business logic. And where you run into problems with this is if those business apps end up broadcasting or interacting with the PubSub in some way. So let's say you want to CD into one of these apps, run tests on it yourself without starting that web app first. You'll end up getting a ETS error, I believe is what it is. I think it's an argument error for ETS because PubSub is not running. And what I've started to do instead is move the PubSub to the uppermost app in your dependency tree, and you'll probably want to define a few functions in there like broadcast, subscribe, unsubscribe. And if you're using absinthe for GraphQL, I think there's 2 functions you have to define there as well that the absinthe endpoint behavior provides. I think it's publish mutation, and I forget what the other one is. But if you create a module like that and then start PG2 from inside that module, you can put PubSub wherever you need in your project. And then in your web app, you just configure it to point to the name of that module. And alternatively, rather than removing it from the web app, you can actually do multiple PubSubs in one deployment. So you could have a PubSub in your business layer that is broadcasting events and subscribing to things. And then if you think of a Phoenix channel, you could have that Phoenix channel subscribe to the business layer, and it can receive a message from the business application PubSub that's in a certain shape. You can transform it to something else, decorate it with something from the connected user session, and then push it through to the browser. So this here is about dependency start order. Eventually in an umbrella project, you'll probably end up with this situation where dependency 1 needs to wait until after dependency 2 is running before it starts. And perhaps dependency 2 provides some access to data storage or something, and dependency 1 does something with that. You can add dependency 1 as an included application, and that will still include it. It means it gets loaded and everything, but it doesn't actually start. And then you're at liberty to start it wherever you need it. Right here we have that child spec declared in the children of the dependency 2 supervisor. So if you needed to start an ecto repo or something, you could do that first, then you could pass in, then you could put the spec for dependency 1 next. And the last part of this section is talking a little bit about multiple Phoenix apps in an umbrella project. So let's say you have this scenario where you have app A and app B doing some complex business logic, and then you have a web application that's Phoenix that is calling into those apps for something. And then you have a business decision that requires you to create a separate web application. Perhaps it's going to be deployed to a different region and you just need something completely custom. For this example, I'll refer to it as perhaps a customer support portal of some sort. So we can run 2 Phoenix applications side by side. One way to achieve this sort of thing would be using Nginx or a load balancer that looks at different paths or domains or something and routes it to different ports, which would be different apps. But we can actually run them side by side on one port by configuring Cowboy. That looks a bit like this. So in an endpoint, where you would typically declare your sockets at the top of the endpoint, if you're familiar with that from Phoenix guides and so on, you can put this here dispatch list that has the declarations in it. And you could also drop this in a mix config file, but I find it a little more natural to put it in the endpoint since that's where people would typically look to add or remove sockets in a Phoenix application. But on lines 7 and 8, we're matching the path for a website. And when you declare a Phoenix socket, it automatically adds WebSocket onto the end of it. So whatever you typically name your path, you'll want to name it that plus WebSocket on the end. And then line 8, it sends it to the Bellevue Web user socket module. And then our new customer support application on line 10, we can match the path that it needs and send that to supportweb.usersocket on line 11. And then line 13 is a wildcard. It says if it starts with support/API and then ends with anything else, we'll send that to the support web endpoint. And then line 15 catches everything else and sends it on to the Bellevue web endpoint that we already had. And then line 20 just merges it into the existing mix config. So this is the last section. This here is talking a bit about deployment in general, how to split up an application and do services, microservices versus monolith and that sort of thing. I think a lot of times when we approach a project, especially if we're used to working with Rails or Django or PHP or that sort of a language, we may think of microservices as being our only option. We just communicate HTTP between them. A request comes into one application, it does an HTTP request to get whatever it needs from another, assembles it, returns a response. And there might be some downsides with that or some things we could improve with that in the Erlang OTP world. And monoliths would be, everything in one spot. and that can have some downside as well. Erlang RPC has the downside of if you have a cluster joined together, you have complete access to any node in that cluster. So there might be some cases where you, for security reasons or something, you need to have services isolated from each other, and you don't want to run a large Erlang cluster. So I'd like to talk a little bit about something that could be in between all of this, just services, decent sized services, not micro and not a monolith, not one big Erlang cluster and so on. And what if we could retain features like message passing, thinking about communicating with other services just by passing it a message, like we do between Gen servers. And if we could keep OTP error handling semantics, let's say that something fails, a supervisor is automatically going to restart, reconnect, retry, whatever that is. And if we could do bidirectional communication so that a service, it wouldn't just be a request response, it would be perhaps a request which sets up a subscription, and then the service keeps pushing data towards the client. And it would do all that over a long-lived connection. So our diagram would end up looking a bit like this. We would have Erlang cluster B, which I labeled it Erlang, but Elixir, OTP family. You'd have that providing a couple services. We have service A, we have service B, and then on the left we have client A, however many clients we need. And that client hopefully is using Elixir, because then we get things like supervisors retrying and so on. We get that error recovery. But it really could be any language, because this connection that we're making to the other cluster is just over TCP. And that introduces the question of how do you discover these other services? We have service A and B, but how do these clients know how many instances there are, which nodes they're on, how does it find them, which ports? And there's a number of different ways to do that. If you're using Kubernetes already, you can create a headless service by specifying cluster IP as none, and then you set your ports to the desired ports you want to listen on, ports 7 and 8. And then on line 3, you specify the name of the service, the one it will be advertised as. And Kubernetes will handle this through DNS. Whenever a pod comes up that has this definition, let's say we're running a replication of 3 for this, it's going to announce that pod on the DNS system. And we could then fetch those items by doing a Erlang DNS lookup. And this is called a service record. You'll notice that get by name in the second position, you're passing an atom SRV, specifying that it's a service record. And this allows wildcards in the lookup. So you can say, give me any service that starts with asset service. And it has a prefix. Kubernetes prefixes that with an underscore. So you would ask for asset service, and then on the protocol TCP, and then the host name would just be wildcard. We don't care where it lives, we just want to know about it. And that returns a result of lines 3 through 5. It's a list of entries. And we're running 3 Kubernetes pods here, and they're labeled asset 0, 1, and 3. And the first element in this tuple is priority. If you're familiar with DNS, that's the DNS priority. The second one is a weight. Since we have 3 items, they're 33, 33, and 33. And then the third element is port 5000. So all of these services are listening on port 5000. So now this client that fetched these items, it knows that all 3 of these are up, and it can connect to them, and it can decide how much traffic to route to each one based on the priority and weight. So all of these are equal, but you could set the weight to be something different. Now, if you're not using Kubernetes, you can use core DNS for one thing. That's a Go binary that serves standard zone files, or it can serve DNS information from etcd, or you could even use Redis or Phoenix Presence or something as an event bus that the application can announce itself on when it comes up. And then you would end up with a diagram that looks like this. We still have our cluster B on the right, and then we have cluster A on the left, but each of these clients is running a process that tracks the DNS based on the time to live, or it's subscribing to Redis or Phoenix Presence or something like that. And that process manages how many connections it opens to each service. And as things drop off of DNS, it can tear them down because that service is fixing to be taken down, or when a new one is announced, it can make connections to that one. So here's a little demo of that working. We're echoing messages, a round-trip message to this service named test service, and we have 3 instances of that test service. And pretty soon a 4th one is going to be announced on the DNS network. And our client process is then going to spin up another connection pool. There it just came online. So it started a pool of 5 connections to that instance of the service. And after a bit, another one will go offline and it'll tear those down. But in the meantime, our messages are flowing across from client A to the service. So now this ends up looking like this. We have service A and service B, and we have the clients on the left that are watching the DNS for new arrivals and for departures, and it's creating a pool of connections to the other side based on what it knows. So then on top of that, we have the concept of streams, which is just a Elixir process on each side. Whenever the client makes a request, it starts a process for that request. And when the server receives it on the TCP connection, it starts a process for that as well. And that's called a stream. You just have a process on each end. Now there's a reference for that request. And so the service does whatever work it needs to do, calls a function or similar, and then it sends that message back across the connection with that reference. And when the client receives that response, it dispatches the result back to the caller, probably using GenServer reply. That'd be the typical way of doing this. And if it's just a short request, that stream can be thrown away. It doesn't need to stay around. But if you're doing something like a subscription, you would keep those processes alive on both sides. And the service end of this could keep pushing events back across that connection to the client. And so what we've done is we have Phoenix PubSub running on both sides of this. We have Phoenix PubSub in cluster B. We also have Phoenix PubSub in cluster A. But there's no clustering done between A and B. They're completely isolated systems, and the message is just passed through on the TCP connections, and then when it's received on the client side, it gets broadcast on the PubSub, which Phoenix channels can listen on, or whatever needs to use them. Now, you can use anything for the transport layer. We're using GraphQL, and you could use JSON, or you could even do just term to binary and binary to term on each side. If you're working with hostile messages, which you probably should count on if you're doing separate systems like this, you'd want to use term to binary safe and binary to term safe so that you couldn't overflow the other side with atoms or do something similar. But GraphQL gives some really nice features, and that would be things like typing. You can define a schema that says, what types these attributes will be, and you can also do subscriptions, which ends up just calling a resolver on the service side of it. So then you can name your topic whatever you need to for your Phoenix PubSub on the service side. And if there's something that errors on the request, GraphQL also gives you a defined, error shape as well. Whereas if you do this in just, JSON, or just using structs and calling term to binary and binary to term, then you need to come up with some sort of agreement on both sides, invent your own protocol. So from that angle, we've enjoyed using GraphQL here. And the other advantage to that is for development, you can run a plug server using Absinthe Graphical, and it can help developers write their queries against this other service in the browser. And additionally, let's say that you also have a request for mobile applications or some other service to fetch things just over HTTP. You could also expose the very same schemas that are being used across this long-lived connection. So since GraphQL is used as a common format communicating with other clients, it can be used in multiple places all at one time. So to wrap up, I'd like to talk very briefly here about a protocol that my coworker Andrew Bennett pointed out to me. Google has been working on this for a while, and it looks like it has gotten some pretty good traction. And it does this same sort of concept as what we were talking about on this last slide here, of making connections between services. And I think that it would be an amazing thing to use for inter-service connection within a local network. They're currently shipping it in Chrome. It's been used for a little while now against YouTube and other similar Google-owned sites so that they could test it out in the wild. But what it does is, some people have called it TCP2, and it is basically implementing TCP using UDP packets. And that sounds crazy, but what it does is, I copied this from their documentation, but here's a list of what they advertise it as. And a couple of these are pretty amazing. The multiplexing without head-of-line blocking. If you have some packets that are slow that the other packets require, that doesn't end up holding up all of your communication. And last to forward error correction, they're building it so that each packet contains, I believe 10% of the packet is reserved to contain data from other packets. And so if one packet goes missing, it doesn't have to retry and request that packet again from the origin. It can reassemble that data from the 10% of all the packets it's already received. And the last one is really exciting, connection migration. So, currently with TCP, a connection is identified by the host name and port, but with QUIC, the connection is just identified by a reference. And so the host name and the port can change. It doesn't matter. The QUIC protocol will negotiate what a connection actually means. So if you think about that, a mobile device can have a connection open, which to our applications would look like a typical socket connection. And if they're on the cellular network and then they walk into a building and their phone connects to Wi-Fi, that connection doesn't need to break. QUIC just handles that behind the scenes as they transition from one network to the next. And if we think about that on the back end, how that could benefit us, a load balancer could take a connection in and then hand it off to a worker node. The connection is created against the load balancer. Then that load balancer hands it to a different node, which then maintains that connection. And let's say that node knows it's going to go down for maintenance. It could hand that connection back to the load balancer, which then dispatches it to a different worker node. So I think this is something to keep an eye on, and it would be amazing if we had something down the line of Gen Quick or even a NIF that would use official C libraries soon, that we could make use of this for the type of service communication that I was describing a couple slides back. And that's it. Thanks for listening. I think I'm about out of time, but I will be around if anybody has questions. I'd be happy to chat about any of this.